Dear students, today in this presentation we are going to discuss about the basic differences between the two types of combinations of resistor. The first type of combination of resistor is known as the series combination and the other one is the parallel combination, as we have already discussed. Right, now the first point of difference is always the definition. Now what is the series combination of resistors? When the resistors are connected end to end, that means one after the other, such that there is only a single path for flow of electric current, then this type of combination of resistor is known as the series combination. Now whereas in the parallel combination, the resistors are connected between two common ends. They are connected between two common ends such that there are multiple paths or branches for the flow of electric current. Right. The second point of difference. Now in series combination, there is a single value. That means the same amount of current flows through all the resistors in case of series combination, such that I, that means the amount of current which is flowing, is equal to I1, which is the current flowing through the resistor 1, I2 the current through the resistor 2, and if there are n number of resistors, the same amount of current will flow through each and every resistor. So there is only a single value of current through the series combination. Whereas in the parallel combination, the current gets divided into number of branches, number of paths, such that their total current I is the sum of the individual currents. That means the current through the branch 1 or the resistor 1 is I1, the current through resistor 2 is I2, the current through resistor 3 is I3. If there are n number of branches or resistors, the current through the nth resistor or the branch is In. So if we sum up all the currents in the branches, then it will come to the total amount of current, that is the I. The third point in case of series, the potential difference, which is V, gets divided among the individual resistors, such that the total potential difference V is sum of the potential drop across each individual resistor. Now in case of the parallel combination, the same potential difference, that is the V, is available to each and every resistor, such that the total potential, if it is V, it is available to the branch 1, which is the V1, which is equal to V2, which is equal to V3, and if there is n number of resistors or branches, each branch or resistor will have the same amount of potential difference, that is V. Now in case of series combination, if one of the resistor breaks down, if it breaks down, that means if it does not work, right? So if there is some breakdown, if it does not work, then all of the other resistors will also not work, because there is a single path for flow of current. So if one of the resistor breaks down, there will be the continuity of the circuit will be broken and no other resistor will receive the current, right? But whereas in case of parallel, even if one of the resistor breaks down, if it stops working, even then the other will keep on working, because there are multiple paths, more than one path for the flow of current, and this is one of the basic advantages of parallel combination of resistors. Right, the equivalent resistance of the series combination. What is equivalent resistance? We have already talked. If you replace all the resistors of that series with one resistor, such that the amount of current and the potential difference of the circuit remain same, so that single resistor which can replace all these resistors is known as the equivalent resistance of that circuit, right? So for the equivalent resistance of the series combination, the expression, or for finding that, is this formula gives us the expression, that is RS, that is equivalent resistance of the series combination, is sum of the individual resistances of the resistors. So if there are n number of resistors, that is the equivalent resistance of the series combination will be equal to sum of all the resistances of all the resistors in the series combination. Now the last but not the least, the series combinations are not very much in use, but they are used in decorative lights, which are like the दीपावली decorative lights, जिसको हम दीपावली की लड़ियां कहते हैं। वो लंबी लंबी जो लड़ियां होती है जो हम सजावट के लिए यूज करते हैं, उनके अंदर हम सीरीज कॉम्बिनेशन यूज करते हैं। बाकी सीरीज कॉम्बिनेशन का ज्यादा यूज नहीं होता, बिकॉज ऑफ सम basic disadvantages, right? Now in case of parallel combination, the equivalent resistance of a parallel combination of resistors is basically is the reverse or inverse of the equivalent resistance of parallel combination is equal to the inverse is, or we can say it is equal to the sum of the reciprocals of the resistances of the individual resistors included in the combination, right? And these are used in most of the domestic, industrial and commercial setup, like in our school, like in our offices, like in our homes. All the combinations which are used up are the parallel combinations of resistors. I think that you have got a fair idea about what are the differences between a series combination and a parallel combination. We are also going to look at the circuit. Now students, let us look at the circuits, right? So that we can understand more about the difference between the series and the parallel combination. Now in this circuit there are three resistors, right? This one is R1, R2 and R3. You know, these are the symbols, right, for the resistors. Okay. Now as we key in, that means when we switch on, the current starts flowing from this battery. There are two cells which are combined, so this is a battery. Okay, so the current, it basically starts flowing and it reaches, and this ammeter which is fit here, it basically measures the amount of current flowing through the circuit. And suppose the reading is I, the I amount of current is flowing through the circuit now. Now this current basically flows and it basically passes through R1, right? It passes through R1 as there is no division, as there is no other path for flow of current. The same amount of current, it which basically starts from this, which basically is measured by the ammeter, it passes through R1. The same amount of current passes through R2 and the same amount of current passes through R3. And therefore we have said that there is a single value of current in case of series combination. Now what happens? The electrical charges are given the potential energy by the battery. Now this potential energy, when the electric charges they pass through this resistor, they have to work, they have to make their way through this resistor, because this resistor offers resistance. Now when they work, they will lose some of their potential energy. Now this potential drop across the R1, we have measured with this voltmeter which is connected across the R1, and suppose the potential drop is V1. So V1 is the potential drop which is when the current or the electric charges they pass through the resistor 1. Similarly, when the electrical charges pass through the second resistor, more amount of potential energy is used up, right? And this drop in potential across R2 is V2, and similarly the drop in potential across R3 is V3. So the total potential which was given by this battery has been used up in these three resistors. So we can say that the total potential V is equal to sum of the potential drop across the individual resistors, right? So in series combination, the total potential is equal to the sum of the potential drop across each individual resistor. Whereas for the current, there is same amount of current, there is single value of current through each resistor. That means there is single value of current throughout the circuit, because the same amount of current will flow through the first resistor, the same amount will flow through the second and through the third resistor, because there is no other path for the current to flow, and the current does not get reduced. The same amount of current which started from the battery will end up in the negative terminal, right? But now let us come to the parallel combination. Now once again in parallel combination, we have taken the three resistor R1, R2 and R3. Now when we key in, that means when we switch on, the current starts flowing because there is a source of potential energy. This is the battery, right? Now this current is measured by this ammeter. This current, suppose it is I. Now this current comes here, and here you can see here there is a junction. Now here there are three branches. Now so the current I gets divided into three parts, right? The current which is flowing through the resistor 1, we have named it as I1. The current which is flowing through, passing through the second branch, that is the R2, is I2, and the current which flows through the resistor third, we have named it as I3. Suppose we have installed ammeter here, right? So which have measured this, the value of I1, I2 and I3, right? So suppose there are small, these are the ammeters which have measured the reading of current. Okay, now the amount of current, once again the amount of current does not get reduced when they pass through resistor, you know. So the same amount, that is I1 comes here, I3 comes here, I2 comes here and I1 comes here. Now once again they unite, they join, they combine here, and once again the current becomes I, because here once again all the three current, that is I1, I2 and I3 have once again combined at this place. So once again the current which flows through this part of the circuit once again becomes I. Now what happens to the potential difference in case of parallel combination? The same amount of potential difference is available to each and every resistor, to each branch. Why each branch? Because suppose this battery is giving a potential of 12 volt. So this same. So what happens? The current when it comes here, the electrical charges have the same amount of potential energy, that is 12 volt. So when the current which is here I3, it flows through this resistor and then it comes once again to this part. This part, suppose now this part is carrying a potential of 12 volt, suppose, and therefore this part will have a potential of 0, therefore 12 minus 0 will be 12 volt. Okay, right? So this part of the resistor is having 12 volts of potential energy, but when the current reaches here, it has 0 amount of potential energy, right? So same implies here, when the current reaches here, it has 12 volt of potential difference, but when it reaches here, that means here means it has reached this point, minimal resistor, minimal potential difference, so once again 0. So that means when the electrical charges pass through any of the branch, they will lose all the available potential, right? So the potential drop across R3, R2 and R1, if we label them as V1, V2 and V3, then V1 is equal to V, V2 is equal to V1 which is equal to V, V3 once again is equal to V2 which is equal to V1 which is equal to V, right? So these are the two basic take homes, that the amount of current in case of parallel combination gets divided into number of branches. The total current is sum total of all the currents in the branches. Now the total potential difference is available to each and every branch, so that or such that you can say the total potential V is available to the branch 1 which is V1 which is equal to V2 which is the potential available to the branch 2 or the resistor second, or V3 which is the potential available to the branch 3 or the resistor third, right? So this is the basic difference between series and parallel combination of resistors. Thank you very much.